Hello everyone, in this video we are going to talk about the number bases. You already know about the base 10 or decimal and you dealing with base 10 numbers in mathematics courses. But here in the digital logic we are going to introduce three new bases, which is the binary base 2, octal is base 8 and hexadecimal is base 16. And learn how you could convert any number between these four different bases that you have. So let us start in general case. Suppose we have one number, which is that number has some digits on the left side of the point, so which I actually label A, B, C, D. So this is your point, and suppose it has 3 digits on the right side of the point. E, F, G actually is the 3 other labels. So that means this number has 4 digits on the left side and 3 digits on the right side of the point. So it could be actually have any number of the digit here. This is just the example. So if that number is in base R, so which is R could be any number and any bases, but here we are more interested on R equal 10, which is the decimal. R could be 2, we call that binary, and also R could be 8, we call that octal, and R could be 16, which is the hexadecimal. So R could be any number, whatever we are actually mentioned here as a rule, it's right for any bases between these bases. That means it's right for base 7, 5, 4, but these 4 is what we are interested in digital logic. So if this number is in these bases, what it means? Definitely it means the all digits that you have and they build this number, which is here is A, B, C, D, and end up with a G. So all of them should be smaller than your base, which is R. So let's actually see what it means in different bases. So for example, whenever R is 10, what it means? So it means the all digits should be smaller than 10, right? So whenever R is 10, so the A, B, and all of them should be smaller than 10. What it means? It means A and B and all digits that make your number, they just could get these numbers 0, 1, 2, and end up with 9. So that means in base 10, you never have number 10, right? The all digit just could be 0 and 1. So example. So for example, this is one number in base 10, which is 129. So each digit is just could be between 0 and 9. So you could actually change the base. If R is 2, again, this rule that you see here is right. The all digits should be smaller than R. So that means, again, A and B and all of the digits that make your number should be smaller than 2. So what it means all digits just able to get 0 and 1. They are actually should be smaller than 2, 0 and 1. So that means in the base 2, this could be a right number 0, 1, 0, 1. So, and the all digit just could be 0 and 1. So 129, which you have here, could be in the binary. The answer is no. In the binary, the digit just could be 0 and 1, not other numbers. So 129 couldn't be a binary, but 01.1 could be in base 2. So the same thing for the octal. So you say R equal 8. So then same rule, A and B, C, that means all digits should be smaller than 8. So that means they could be just 0, 1, 2 to end up with 7, right? So example. So 125 could be in base 8, yes, because the all digit is between 0 and 7. Is 129 is in base 8, The answer is no, because in base 8 you couldn't have 9, or number should be between 0 and 7. And finally, we actually keep r equal 16. So same rule, so the a, b, and all digits that make your number should be smaller than 16. So that means a, b, and all digits just could be 0, 1, and end up with 10, 11, 12, 13, 14, and 15. Could we have 16? No. So the whole number should be smaller than r. R is 16, so that means the biggest number that you could make is 15. But here, after 10, you actually give a name for each of them. So 10, you label that A, 11 is B, 12 is C, this is D, this is E, and this is F. So, example. So AF1 is one example in base 16, okay? 1 to 1 could be in base actually 16, because all digits that you use is between 0 and 15. So this is actually is introduction to the number base. So these rules that I mentioned here is right for any bases. But in the digital logic, we're more interested on these 4 bases that you see here, which is decimal, binary, octal, and hexadecimal. In the next video, you will learn how you could convert any number that you have in base R. You will be learn a formula that you could convert that number to the base 10. So thank you for watching this video.